Hey guys, Professor Floyd here. We are going through homework set 8 and we are going to do number 2 right now. Or at least I'm going to walk you through number 2 and tell you what the answers are. So in number 2, it's just a real basic calculate the time-weighted average of 3 consecutive VOC samples. I think we're measuring toluene. Each sample is 160 minutes. And we're asking for an 8-hour TWA. So the thing to recognize is that 160 times 3 is equal to a full shift, 480. Okay, so there's nothing to recognize there. So I have told you OSHA visits your plant. You have one employee that's sampled for toluene using 3 successive sorbent tubes using NIOSH method 1501. And we get the following results: 92.3 ppm, and time 160 minutes. Okay, let's see, 151 and 84.6. And these are all 160 minutes. So this is pretty straightforward. I've asked you to tell me what is the 8-hour TWA that OSHA measured on this day. So TWA is just going to be your concentration at time 1, concentration 1 times 1 plus concentration 2 at time 2, all the way out to concentration N. In this case, it's just we just have 3 concentrations, so concentration 3, time 3, and then that divided by all of your times. So time 1 plus time 2 plus time 3. So this was 160 times 3, so this is 480 minutes. And then this is just the way that you're weighting each one of these concentrations for that duration of time. Since these are all the same, this is really kind of a trivial question. And so this comes out to about 109 ppm. Okay. So then I ask you to report the PEL, REL, and TLV for an 8-hour exposure to toluene. So this is just wanting you to learn how to find these things. It's not terribly difficult. You can find it on the OSHA website. If you just type in OSHA and toluene, and then look at their chemical data. Scroll down a little bit. They have exposure limits from different times for OSHA. They have NIOSH. They even list the ACGIH. They list an excursion, a ceiling, and I don't know, they list something else too that I wasn't used to seeing. You go to the NIOSH Pocket Guide. They list the OSHA PEL and the NIOSH REL. You can go to the ACGIH documentation for TLVs, or you can go to the TLV book and get that TLV that way. So there's a lot of ways to find this information. In this case, the OSHA website was the best. So you can find them all. And so we find that the PEL is 200 ppm. The REL is 100, and the TLV is 20 ppm. Okay. So then I ask you, what would be the OSHA compliance officer's determination? So if you remember, the OSHA compliance officer is looking at, he has a measurement, and he recognizes that measurement could be something in this range. It could be some value within a normal Gaussian distribution. And so he has the most probable value. He believes that this number represents the most probable value that he could have obtained that day. But he recognizes that it could be that the stars just aligned poorly for him, and his pump was fluctuating on the high end of its tolerance, and the lab was on the high end of their tolerance. And so it could be that he's actually giving a 95th percentile overestimate. And so what he wants to know is that based off of the value that he does have, how low could that value possibly have been given the type of error associated with using this technique to measure an exposure. And so the sampling and analytical error for this method is given as 9.3%. Now that's 9.3% at the permissible exposure limit. We don't really go into that, but if you're at half of the PEL, which we roughly are, and you've got 9.3% variance, then just suppose that's 100, then our value would be 100 plus or minus 9.3. But if you're at 200 PEL, then 9.3% is 200 plus or minus like 18 ppm. So this sampling and analytical error is standardized to the exposure limit. So just bear that in mind. So Mr. OSHA is going to say, all right, well, I have the exposure fraction. Well, first, Mr. OSHA is going to say, my average is less than the exposure limit. There's not an over. This sample does not demonstrate non-compliance. So it's a double negative, meaning that I have no reason to suspect non-compliance. He's not going to say it's a compliance sample. He's just going to say this does not exhibit non-compliance. So he's going to stop right there, and he's not going to calculate the lower confidence limit. But if he were to do that, he would calculate the 5th percent. He would calculate basically the 5th percentile value of his possible exposure measurements. And then, however, your company wants you, as the good industrial hygienist, to demonstrate that that value that Mr. OSHA collected for you is actually demonstrating that you guys are compliant on that particular day. And so what you're going to do is the converse of the compliance sample. You're going to look at the upper confidence limit. So you recognize that this is a measure, but it could be that things were being sampled slowly or the lab was giving a low value. And so the real value could be all the way out here at the 95th percentile. So what you would do is you would say, we'll take the mean and then we'll add 1.645. Wait a minute. Make sure I'm doing that. Let me reference my skill set here. I don't want to tell you guys wrong. Yeah. 1.645 standard errors. And so in this case, the simple thing that we're doing right now is we're just using the sampling and analytical error. Typically, OSHA is going to try to collect a single sample, so that n is equal to 1. But it should be times the standard error. If you remember, standard error is equal to the standard deviation divided by the square root of n. So if you've only got one sample, then standard deviation and standard error are the same thing. If you've got 3 samples like we have today, then the standard error and standard deviation will not be the same thing. So our average is 109 ppm, and then 1.645 times 9.3%. Yeah. Oh, I should have changed this 109 into the exposure fraction. So it would be 109 out of 200, which comes out to something like 0.54. And then this would be 0.093 divided by the square root of 3. Okay. So when we do that, we should find that our upper confidence limit, make sure that that's how I calculated it, yes, is equal to 0.63 exposure fractions, x's, exposure fractions. And so we then have to multiply by the exposure limit. This 200 is our exposure limit. So multiply by 200, and that gives us our ppms. So what's 0.63 of 200? It's 127. And so you would say, indeed, Mr. OSHA, you collected that sample. It did not show that we were non-compliant. And I say it showed that we were compliant, because the 95th percentile of that exposure that you measured is 127, and that is well below your exposure, the permissible exposure limit of 200. And so you'd pat yourself on the back and you'd say, all right, we're doing a great job. But then I ask you, do you have any concerns with this exposure? And you might say, no, it's 127, and OSHA's limit is 200. We're good to go. But as a self-respecting industrial hygienist, you should recognize that the recommended exposure limit and the threshold limit value from NIOSH and ACGIH are both health-based standards, whereas the PEL was originally health-based because it came from the TLV, but then it has to go through literally an act of Congress to be updated and changed. So the PELs are old and out of date, and there's feasibility to implementing these that comes into play. The REL and TLV are updated simply based off of health data. So if the REL says 100, then that means that that's the point at which you're having negative health effects. And so if the TLV says 20 and you've got an exposure roughly 5 times that of 120, then you should not find this acceptable. And indeed, if you're a CIH and you are bound to the ABIH Code of Ethics, then you would be obligated to notify your company, or if you're a consultant, notify your client that they have exceeded the REL and the TLV and that they should lower those exposures. So, and if you're working for the company, then you would tell your boss, this is good, we don't get a citation today, but we need to lower our exposures. Plus, with variation like we saw in this sample, your true 95th percentile exposure on some other day is most likely going to be well above the exposure limit, and your exposure, your exceedance fraction, which we'll calculate in a couple of examples, is probably going to be in the 10 to 15% range. And the generally accepted proportion is 5%, since the permissible exposure limit is supposedly an absolute no exceeding of this value. There's the working understanding that, well, nothing's absolute, but if you keep the frequency of overexposure to less than 5%, then that meets the spirit of what the PEL means. So with an exposure of 127, with an average exposure of 127 ppm, and the variance that we saw here, you most likely will have more than 5% of your exposures exceeding the permissible exposure limit. So you should definitely have a problem with this level of exposure.